everyone, I hope you are doing good. So today in this video we will take a new DSA question here which got recently asked in one of the interview. So delete a node from BST. So I hope you understand binary search tree and binary tree, right? Binary tree means the tree will have maximum 2 child nodes, correct? And binary search tree means it is also binary tree, but the one more basically property of binary search tree is if we traverse this in order, then the output will be in sorted, right? So here output would be sorted. So for example, this one, right? 2, 1 and 3. This is the binary search tree. Why? Because if we go and print the output in order manner, right? In order manner, then our output would be sorted. This is the one way to check. The other way is the left subtree, the maximum value of the left subtree would be less than the value of the node, right? So node value is 2 and the maximum of left subtree is 1, right? So it is less than, correct? And we always like greater than the parent value or the parent node value, correct? So here the minimum is 3 and here we are getting 2. So this is the simple example. I will take another complex example and also show you the same like properties, right? So let me take you that. So here also you can see, so this is also a binary search tree, right? And here this is the main head, or you can say top root node, right? And if the maximum of the left subtree, right? So this would be the left subtree, correct? This would be the left subtree. And here the maximum value is 7, right? So 7 is also less than the 9, correct? And here if we go right side, then the minimum value is 13 here. This is the minimum value 13. And this 13 value is also greater than the 9 value. Right? So that is what I was telling you, right? The minimum of the the maximum of the left subtree should be less than the root node value, and the minimum of the right subtree should be greater than the root node value, correct? So that is the property of the binary search tree. And each and every node here is having either 0 or 2 child nodes, so it is binary tree, because in binary tree maximum child node can be 2, correct? So I hope you understood it. This is the quick explanation. So now coming back to our question here. So now our question, let's understand the question first here. So given a binary search tree and a node value x, right? So one binary search tree will be given and a node value x, right? X value will be given, which would be a value of any node. Delete the node with the given value x from the BST, right? We have to delete that node which is having the x value, right, in that binary search tree. If no node value is given, if no node value x exists, right, then do not make any change, right? In that case, if any node is not having x value, then we do not have to make any change, right? Then return the root of the BST after deleting the node with value x, right? So it is saying once we are done with modification with deletion of that x value node, then after that we have to return the root, right? Root modified tree, basically, right? So I hope you understood this. Let's take this some examples here. So here first example is, so this is the binary search tree, right? Because left value is less than the root node value and the right value is greater than the root node value, correct? So now this is given, right? And here x is also given 12. 12 is not there in the binary search tree. So what we will do, we will not make any change, right? Whatever the root we have, we will return that only, right? So here that is what we are doing, and we are returning 1, 2, 3 only, right? We are returning same. Now take the second example here. So here second example is this one. This is the data which is given. So we have here it is represented as a binary search tree, right? And then the x value is 11. So now we have to delete the 11, right? Where is the 11? 11 is this one. So this node must be deleted. So here we will delete this one, and then we will return the root node, right? And then we will print, then the 11 will not be there in the output. So see here, here we see 11, but here we don't see 11, right? 11 is not there. After 8 we see 12, correct? That is here, and then 9. 11 is gone because we have deleted the 11 node, correct? How we can do that I will explain, but let's understand the question. So I hope you now you are clear with the deletion. Take another one more example here so that the understanding would be clear. So here it is given 2, 1, 3, right? And we have to delete 3, right? We have to delete 3. So this 3 node must be deleted. That is what the expectation of the question. So what we will do, and after deletion of this one, only 2 nodes will be there, right? Only 2 nodes will be there. This is 2 and this is 1 because 3 is gone, correct? So now see here, output is 2 only, and our representation of the 3 after modification, we see only this one. So now this is the question. I hope you understood, where we will be given one x value, any node value. If it is there, then we have to remove that node from that tree, and we have to return the root of the modified tree. Correct. Now coming back, now think about the solution. What could be the solutions here? And I'll explain whatever I am thinking. And the internal representation of the tree is this one, right? Here we have the structure node here, right? Tree node, and here we see data, and we have left and we have right. So in node we are having 3 field, right? So it will be like this one, right? This is for data, this is for right, and this is for left. So this is the representation of the node of the tree. So now first take one example here. So here what we are doing, this is the given binary search tree, right? This is given binary search tree, and we have to delete 3, right? So what we will do, we will start from here, correct? And we will check if the 3 is less than this one, then we by using the property of the binary search tree, what we will do, we will go left side, because 3 is less than this one, and the minimum lesser value will be left side only, right? So what we will go left side only, and then we will check this node. This is also greater than 3, so we will go left side. Yes, here we will come here, right? Here this node, and here what we will do, we will check, yes, 3 and 3 are equal, so we have to delete this node. Now before deleting, we will check it is having left node. No, it is not having left node, right? And it is having right node. No, it is also not having right node, and it can be deleted easily, right? So what we will do, we will directly delete this node, delete this node, and we will return null, and that null would be the value for the right of the above parent one, right? So after deleting, this tree would be converted like this one, 5, then 3 is gone, right? 7, here 15, here 13, and here 17, and here this is gone, right? So this would be the output, right? This is null, nothing is there, correct? This node is not there basically, so let me remove this one. So I hope you understood this problem, this solution here. So what we are doing, we are checking, if we are starting from the root node, and then we will check. So for this condition, what we can do, we can add a simple condition, right? If the deletion node here, right, the x is less than the root arrow data. If this is the condition which is satisfying, then what we will do, we will then say root arrow left is equals to delete node, and then here we will pass root arrow left and x. That is what we will do, because now we will say go left side, right? Because the x is less than the root arrow data. and then we will recursively call again delete node with the x, and now we will check on this node, and whatever the value we will return, that will be the value for the left. That is what we are doing. And here also we are doing same. So now coming here, this 5 arrow left we will pass, right? And here we will delete this node and we will return null value. So now root arrow left, root this 5 arrow left would contain null. It means no left node now remaining. Correct. So I hope you understood this one. This is the code for this this scenario. Now we will check another scenario here. So here we have to delete 7. So earlier in the last use case we were deleting the left side one 3 1. Now we will delete a 7, right? So now here we will see here 9. First we will check that condition. So this is less than 9. So we will check this one, and then we will go here 5. Now this is greater than the 5. So what we will do? We will go right side. Correct. So in this, right, so we will delete this node, and this is also not having any left or right, right? This is also leaf node, so it can be deleted directly and we can return the null value. Correct. So for this one, after deleting this one, the tree would be 9, 13 and 17, and the 7 is gone. Correct. 7 is gone. So this would be the output tree. Correct. And the code for this one is like we can say, if x is greater than, right, x is greater than root node. See here, x is greater than root node, 7 is greater than root node, so we will go right side. So here we will say root arrow right is equals to, again we will call recursively and we will say delete node with root arrow right and x, right, and x. So what we will say, if the value is greater than the root arrow data, then we will go right side, because that value might lie right side, right? If it is not, then we will not make any change. If it is there, then we will remove that one. So here we will go right side and we will see here this is the value. So here delete node again. For this one, yeah, x is the value, then we will delete this node. So for deleting the leaf node, I will also show you the code, right? So in that case, what we will delete this one. So if root arrow left, right, is null, correct? So let's say null, or we can add this way. So the deletion code is root arrow left is null and root arrow right is also null. Then what we will do, then we will basically directly we can say delete root, right, and we can say return null. So don't worry, I will show you the C++ code also. So here I am just for explaining, I am just adding this piece of code, right, so that you can clearly connect here. That is what we are doing here, right? So this is the code for deletion. That is what you will see in the code also, right? So if left is null, right is null, it means it is the leaf node. Then directly go and delete this node, right? Whatever the node is there, just delete that and return null, because nothing is there left or right, correct? So this is the code for deletion the leaf node, right? I hope you understood this one. Now it will return the null value. So null value would be the here root arrow right, right? So 5 arrow right would be null, correct? Because this node is gone, and the deletion node will not have any left or right nodes, correct? I hope you understood this one. So now take the another example here. So this one here we have to delete the 5, right? 5, and 5 is having left and right. So what we will do, we will start from the root right here, and now this is matching. So this is the deletion node. So what we will check, left and right. Yes, left is having node, right is also having node, right? So we cannot simply delete this one. So what we will do, what I will do, I will check for the next greater value, right? Or you can say the minimum of the right, correct? So that would be the next getter, right? So in binary search tree, the minimum of the right subtree would be the next getter of the root node. That is what the condition is, right? Because that would be the condition. Basic condition is the minimum of right subtree would be greater than the root node, and the maximum of the left subtree would be less than the root node value, correct? So what I will say here, I will come here and I will check next minimum value, right? Next minimum value, that would be 7 here, right? Because we have only one node, so that would be 7. So what I will do, I will replace and see one thing. So this would be either the leaf node value or the node which is not having the left. So that is the here, right? So what I will do, I will basically go and check, yeah, this is the value. So I will replace this 7 with 5, right? So this will be replaced with 7, right? And then I will pass again. So the code is simply if root arrow data, right? This is the condition, this is matching. Then after that, what I will do, I will say then we have to delete this one. So now if root arrow left is not null and root arrow right is not null, right? Then what I will do, then I will say next min value, right? You can say next min. So that would be we can add a separate function here, find next min. You can say find next min, and here we say root arrow right, correct? We can pass root arrow right, and here this value will be here. So now replace this value with this one. So here root arrow value is equals to next min value, correct? So this 7 is updated here, and then again call here root arrow right is equals to delete node, right? Delete node with the here you can say delete node and root arrow right comma next min value, right? Now change here, right? So now we will delete this one 7, not this 5, because 5 got updated here with the 7 value, correct? And why we are not deleting this node? Because this is having left and right sub nodes, basically subtrees, you can say. So that is what we are doing here. Simply we are using the another approach where what we are doing, we are just replacing this deletion node, original node, whatever we want to delete, with the next minimum value of that node, right? So 7, we got 7. So 7 we will delete, replace the 7 like 5 with 7, and then we will say now delete the next min, that is 7 here. Now we are saying now delete node go root arrow right, like this right subtree, and here delete the 7, not the 5, right? And the 7 would be it would be either like leaf node, or it would be having only one node, right? So here it is not have, it is the leaf node, so it would be deleted easily, right? Using the whatever the approach we have discussed earlier in the earlier use cases, correct? I hope you got it. So now moving to the next. So this complete code is there, right? So don't worry, I am just adding this piece of code here so that you can easily connect the dots, correct? So now coming to the next use case here. So this one. So if for example we are having only one node here, right? One node is there, only 9, right? So this is the one node only. So in this case, what we will do, we will and it is matching, right? So what we will do, we will directly delete and we will return the null. That is what we have discussed. So let's take one more example here. If the node is having basically one node, either left, right? So for example, this one, or you can say right, either left or right. Like we have discussed zero node, it means leaf node. We have discussed when the node is having the deletion node with, is having two child nodes. Now discuss the if the node is having one node only, either left or right, right? So what we will do in this case, what we will do, we will check if, right, root arrow left is not null in this case, correct, and root arrow right is null, right? And if it is having a right node, in that case, right, root arrow right, root arrow right is null, right? So here in this case root arrow left is not null. So if it is having right node, in that case root arrow left is null and root arrow right is not null. That would be the condition. Now what we will do, we will say we will take this node in 10. So we will say node pointer temp is equals to, right, root arrow left, because left is not null, right? So we will take in temp here, and then we will delete root, and we will return here temp, that is left. So this node will be returned here, correct? So this is the case. So now take this example here, and here what we are doing, we will check, and the deletion would be here, for example 7, right? So 7 is having one right node here, correct? So what we will do, we will check, we will go here, we will store the temp, right? In temp, what would be the temp value here? That would be 8, this node 1. We will store this node into temp, and then what we will do, we will delete this node, we will delete this root node, and we will return this one. So now and where this returned value will be stored, the left of this 9, right? First we will go here, then we will go left, right? And then we will check, yeah, this is the deletion node, this would be deleted. So then we will check for the left and right. Here left is null, right is not null. So what we will do, we will store this in temp, and then we will delete this one, and then we will return this value to the left of this 9, correct? So this is the simple code, right? This is for left node. You can add this for the right node as well. Here you have to delete the right instead of left, and here you have to check for the root arrow left is null, right, and root arrow right is not null. That is the condition you have to make here. I hope you understood it. It is clear. Now coming back to the code, here I will show you the code here. So this is the node, the binary search tree, right? And now go through the code here. So here this is the main function, right? Delete node, and here we are checking for the this one, for the if the root is null, then just return root, whatever the value is having, right? Null, right? And then first condition we are adding here, if the root arrow data is greater than x, right? It means we have to go left, right? Because the x is less than the root arrow data, correct? So we are going the left side, root arrow left, delete node, and on the left we will do the same thing. So we are recursively calling the delete node here, and then once we are done, then we are deleting the root here, correct? And if the value is greater than x is greater than the root arrow data, then we will go to the right side, correct? And we are returning the root, correct? I hope you are getting it. I have already explained this code. Then here if, right, this is the case, these are the case 2 scenarios where the x is not there, right? X is not matching the root arrow data, basically, right? Now if we found like the node which we want to delete, right, it means x is matching with the root arrow data, correct? So here then we have multiple scenarios. One is if the root is having no child, it means this is the leaf node, right? In that case, what we are checking, left and right are null, right? So just delete that root, right, and then return null ptr or null, correct? This is the one we have already discussed. And the second use case is if it is having one left child only, right? I just explained, right, either left or right. So this is the code for the left, right, where left is not null but right is null, right? So what we will do is just take the root arrow left, which is not null, in temp, then delete root and return the temp, right? And this is for the right, if it is having only right child. And the last one is where it is having left and right both. That is what we have already discussed, correct? So what we will see in that case, we will see next minimum value, right? So we will pass the root arrow right and root arrow right arrow data. That would be the here next minimum value, next minimum value. So it will return the next minimum basically node, right? And arrow data, that will we will get the next minimum value from here, and then we will update the root arrow data with the next minimum value, and then we will delete that next minimum node, right? Basically note the original whatever we want to delete from here. Delete node, then root arrow right, and next minimum value instead of the x what we are passing here, right? Correct. I hope you are getting it. So this is the example. Basically, yeah. So this is the example we took, right? We want to delete 5. So what we did here, we reached here 5, then we check left and right is there. So we found next minimum, that is 7, and we will replace 5 with 7, and then we will delete the 7. That is what we are doing here. Correct. So I hope you understood this one. And if you want this code or any help, then you can ping me, or you can comment below the video so that I will address your queries. Yeah, so that's all for today. See you next time. Till then, keep learning and keep exploring.